Alright, today we're going to learn about trigonometry, and trigonometry is basically kind of like an extension from Pythagoras' theorem, which also talks about right angle triangles, and trig ratios also talk about right angle triangles. Now, trigonometry goes back many years, when the ancient Greek and Egyptians actually used that to do basic calculations for buildings and for also astronomy. Now, if any one of you, well, most of you would know what the pyramids are. So the basic form of trig was used actually to construct the pyramids. Anyway, so moving on, the main things that we need to identify before we start using the trig ratios, well, there's important words. Firstly, ratio. Ratio indicates that we are going to talk about some variables in comparison to each other. And when we talk about ratios, then we have operations of times and divide. So that's one of the main things that we need to keep in mind when we are going to do some questions based on trig ratios. Firstly, the main thing is to identify the sides of the triangle, which we have learned already in terms of the hypotenuse and the opposite and the adjacent side. The thing back to when we did Pythagoras, and when one of the angles is labeled, so the angle over there is theta. Now, as we know, theta is just a Greek alphabet. So it's just an alphabet, but it is used to represent angles. So any side that is across from the theta is the opposite side. Any side that is right next to the theta is the adjacent, and obviously the longest side to the triangle, or the one right opposite the right angle, is the hypotenuse. So this is one of the main things that we need to remember. Okay, when we were doing Pythagoras, yes, we identified the alphabet to use as theta. Sometimes we use alphabets like alpha, and mainly it's theta and alpha, I think, that we'll be using. So we'll just stick to that for now. Now, for a right angle triangle, the trig ratios are basically used to work out the missing sides and the missing angles. So what that means is that if you are given an angle and a side, you would be able to find or calculate the value of the adjacent side to that angle and the opposite side to the angle using the trig ratios. Okay, and the three trig ratios that we're going to talk about are sine, cosine, and tangent. Now, I'm just going to quickly flip up the calculator to show you these on the calculator. So that one over there is sine, that is cosine, and that's tangent. And we have these on our calculators as well. Okay, so identify that on your calculator so you are familiar with it when we start doing some questions. And the way to find the ratios, these three ratios, there's a rule. Okay, and the rule is basically to find the sin or the sine of an angle. Okay, short form is just sin. Sine of an angle is equal to the opposite side divided by the hypotenuse. That's one formula or one ratio. Cosine of an angle is equal to the adjacent side divided by the hypotenuse. Take note that there are some letters which are in a different color, and we'll come back to that as to why that's the case. And the tangent of the ratio is equal to the opposite side divided by the adjacent side. Now, if you take note, then you see that sin has got a capital S, and that is equal to the opposite side divided by the hypotenuse. And that is where so comes. Okay? Cosine has got a C, and that is equal to the adjacent divided by the hypotenuse. That's where the car comes. And then the last one, tangent, letter T, is equal to the opposite side divided by the adjacent side. That's where TOA comes, which gives us SOHCAHTOA. So that's the short form of remembering the three trig ratios. All right, and we'll do some examples now to see how we can work out the missing sides or the missing angles using these three ratios. All right, let's look at the first one. So for the first example, all we need to do is, let's see if we can identify them. All right, so write a trig ratio in fraction form for each of the following triangles. Now, as you look above, if you see in each of the triangles, we have tried to identify the sides first in relation to the angle that is given. Very, very important. So the first thing you do is to look for the angle that's given. Now the angle given is here. Then what you start doing is you start labeling the sides in relation to that angle. Okay, so the side right next to the angle is 5, which is the adjacent side. The side opposite to the angle, we don't know, there's no number there, so that is the opposite side. And obviously the longest side, or the side right opposite the hypotenuse, the right angle, is the hypotenuse. So in this first example, we see that we are given A, which is equal to 5. We're given H, which is equal to 7. So the two letters that are used are A and H. Now, let's think to our so, ka, and toa. Let's have a look. Which, out of SOHCAHTOA, which one uses A and H? Yes, it's that one. So therefore, that tells us that we have to use this ratio to work out the missing side. Now, are we asked to find the missing side? No. All we need to do is to write a ratio in fraction form. So the way we do that is to write the whole ratio first, the formula of it, which is cos of an angle is equal to adjacent over hypotenuse. And then we just substitute that. So basically cosine of an angle is equal to 5 over 7. It says in fraction form, leave it like that. And that's it. Let's do the second one. Let's identify. So we have got 4 as the opposite side to the angle, and we have the hypotenuse. So let's write that down. The opposite side is equal to 4. The hypotenuse is equal to 9. O and H. O and H is so. So let's then write the ratio, which is sin theta is equal to O over H, which is equal to 4 over 9. So therefore, sin theta is just equal to 4 over 9. And let's do the third one. What's given is the opposite side, which is 3, and right next to it, which is 5. So A is equal to 5, O is equal to 3. O and A is TOA. So let's write our ratio. Tangent of an angle is equal to O over A, which is equal to 3 over 5. Okay, pretty easy. All right, now let's move on to the next step. So the first thing is to, very first, identify your sides in relation to the angle, whether they are O or A. Then you decide out of these three ratios, which one you're going to use. And then once you've decided that, you substitute those values and you have come with basically a ratio or a formula or an equation. The next part is where, yes, we do all of that, and then we have to actually calculate a missing side or a missing angle. Okay, so the first thing we'll do is just calculate a missing side. Now, if you have a look, the main thing is that you need to identify first which ratio to use. So if you have a look at the example that's given over there, for these three shapes, these three triangles, in relation to angle 30, x is the opposite side and 3 is the hypotenuse. So therefore O and H uses so, and that's why we come up with that, the sin equation. And then we just substitute. So sin of 30 is equal to x over 3. To find what x is, you do the opposite, times by 3 on both sides, and you get x is equal to 3 sin 30. Now let's do an example ourselves. Let's do, okay, it's example 2. Let's write a value there. So that is 60 degrees. So that is 4, and we have to find x. Okay, so that's the angle. What's given is right next to that, which is the adjacent side, and then the hypotenuse. Okay, so if you have to work that out, so A and H is ca, which means it's cos theta is equal to A over H. Let's substitute. So cos of 60 is equal to A, which is 4 divided by hypotenuse, which is we don't know, x. Now, let's see if anyone remembers, what do we do when our unknown is in the denominator? Think back, we swap these. So therefore what we get is x is equal to 4 divided by cos 60. And this is where we bring our calculator. And we go 4. Let's move this. Oopsies. What have I done? So let's move this down slightly. Okay, 4 divided by, and in brackets, let's say cos 60, close brackets, and equals. And that gives us, now that doesn't make sense. Obviously, there's some mistake that we have made. Let's see what happened there. Okay, let's try again. We'll use this other calculator because in that other calculator, the mode or the mode of the angle was not correct. So we'll do 4 divided by brackets cos of 60, and that is equal to 8. So there you go. It's equal to 8. So therefore the answer that we get for x is equal to 8. Okay, let's try another one. $40 degrees. 10. And I'm going to say centimeters. Okay, so let's first label our sides. So if you have a look, right next to that is adjacent, right opposite that is x. And if we just write that down, we have got A is equal to 10, O is equal to x. So A and O, the ratio that uses A and O is TOA. So therefore we have tangent theta is equal to O over A, which is tangent 40 degrees is equal to O, which is x, divided by A, which is 10. Okay, so now we backtrack, so times by 10 on both sides, times by 10 on both sides. Now notice that I haven't worked out tangent 40 at this stage. And the reason for that is accuracy. So you want to go right down till the end before you start working out, because what you'll notice is that sin, cos, and tan of numbers don't always give you exact whole numbers or exact values. You'll get a long decimal or irrational number. So therefore, you have to go right down to the end to decide. Okay, Okay, if you see the calculation, it gives us as 8.39. It's approximate, and that's what you write. I'd indicate with that.